Welcome back, Science Gang. We're going to look at the average speed assignment, exercise 2. I'm going to run through one of the calculations and I'll get you to run through the second calculation. So when you hand it in, you'll have both calculations done with some help from me with one of them, and then the one that you did yourself. So this is average speed, exercise 2. Just reading the original question here. Sonia and Kyle have each won a scholarship to attend a summer science camp in Kingston. The scholarship includes the cost of a round-trip ticket by bus, train, or airplane from their homes to Kingston. Their hometowns are Toronto and Windsor. So we have some data here. The following table gives the distance from their hometowns to Kingston and the time it would take them to get there by bus. Okay? And I want you, in the question, calculate the average speed. So you're given distance, time, asked to find speed. So this uses the old equation that we had from the previous video. Average speed equals change in distance over change in time. So we're going to be using that. And if you recall, there is a neat way of rearranging things with that equation, using this, what I like to call pyramid power or the triangle of terror. You can be the judge as to what you want to call it. So we put the V there, the D there, the T there. We can get all of the equations that we need to figure anything out here. So with this particular question, so you can always pause the video and get that down. Over here, we're asked to find the speed. So VAV is the question mark. We're given distance, so 255 kilometers, and we're given the time, T, 3.08, and this is in hours. So I'll go over Kyle's information, or sorry, I'll go over Sonia's information, you can go over Kyle's. So Sonia, I'll write it right there. So we're looking for V. So looking up here, we just simply use the original equation here because V is isolated, and we're going to calculate by taking D divided by T. Quite straightforward there, gang. So VAV is equal to delta D over delta T. And in our case, we have 255 kilometers divided by 3.08 hours. And when you figure that out, you should get, I think, 82.8. Now, the units. At the last assignment, they were meters per second. But in this case, our distance is kilometers, our time is hours, kilometers over hours, kilometers per hour. So 82.8 kilometers per hour. So you can do the same thing over here. Set up this part again, even though you kind of know that we're looking for speed, you should set it up over here like that. And then do this calculation with Kyle, see who's faster from their hometown. If we look at the second question, somewhat similar information, but we're asked to find something different in this one. So because trains and buses travel different routes between one city and another, the distances they travel are not the same. The table below gives the average speed of each train trip and the distance traveled. And here the question is, calculate the time it would take. So if I'm looking at, once again, I'll look at Sonia's information. And over here we have, we're asked to find time. So T is the question mark. Distance we're given. In her case, it's 240 kilometers. And we're also told the speed, the average speed, 95 kilometers per hour. So we're asked to find different information here. Now, if we're looking for T here, so going back up to here, our little rearrangement, if we're looking for T, it is D divided by V. So this triangle here, or pyramid of power, helps you figure out the unknown. T is equal to D over V. T is equal to, triangle T, delta T is equal to D over V. You can see how easy that is to set up. D is 240 kilometers. V is 95 kilometers per hour. And when we figure out this, let's see, I did it earlier here, we get 2.5. Now the units are somewhat tricky here to manipulate. We have kilometers over kilometers, which cancels out. And on the denominator of this fraction, we have kilometers per hour. Now what happens there is that unit gets inverted and multiplied, so the hours ends up being on the numerator. So 2.5 hours. But a little trick that you can use, whatever time unit you have in the speed, that's going to be your time unit. Kilometers per hour, my t is going to be in hours, assuming that the d and the distance and the kilometers have the same distance part. So you can go ahead and figure out Kyle's information there, same way. And then the last part of this question, number 3, as with trains and buses, the average speed of airplanes is reduced if there are stops along the way. The table gives the average speed and the time taken. And the question here, the only thing we haven't been asked to find yet, is the distance. So in all of these, we're going to be asked to find the distance traveled. So once again, I'll go through Sonia's information here. So looking for distance traveled, going back to the pyramid of power here, we're looking for D, V, and T are side by side. And as I mentioned in the other assignment, treat that as multiply. So V multiplied by T. So D multiplied by, so delta D is equal to V multiplied by T. So I can write them side by side, little dot there to represent multiply. Usually don't write the x because we may get confused with variables. So here average speed is 310 kilometers per hour, and t, I'm told, is 0.8 hours. So substituting that information in here, 310 kilometers per hour multiplied by t. So I'm just using brackets here to demonstrate multiplication here. Okay, and the units here, interesting. Kilometers per hour multiplied by hour. The hour in the denominator cancels with the hour in the numerator, just like you can cancel numbers when you multiply fractions. You can do the same thing with units here. Our final answer, our final unit will be kilometers. And we multiply that all out, you should get 248 kilometers. So with this is a neat assignment because it goes through all possibilities with that average speed equals displacements over time equation, and using that pyramid of power or triangle of terror, whatever you want to call it, we can easily solve for the unknown.